Welcome class. Today we're going to be talking about quadratic equations. And so far in algebra all we've talked about is linear equations. And linear equations are great and they're fun because the line is straight and they're really easy to work with. The problem with linear equations is life doesn't always give you straight lines. Sometimes there's curves and obstacles in the way. So I want you to picture yourself for a minute on the free throw line, shooting a game-winning free throw. Okay? And if you shoot your ball in a linear fashion, if you just throw it in a straight line, the problem is you're not going to make too many free throws. You're going to end up like Shaq. Okay, so quadratic equations allow us to form arcs or parabolas. Okay, and we want our free throw to go in a nice arc, a nice parabola, and end in the bottom of the net. Okay, so let's take a look at some quadratic equations and things that line up in that direction, just like a free throw in a parabola, in an arc. I want to get started with some vocabulary words. So I've got some vocabulary here posted behind me. You should be able to find these same vocabulary in your notes if you can just follow along in your notes with me. The first thing I want to talk about is standard form of a quadratic equation. Okay, the standard form of a quadratic equation is y equals ax squared plus bx plus c. Now that's usually the way that you'll see quadratic formulas or equations written. If you see a quadratic equation that's not written in standard form like that, then you should quickly convert it to this form. It'll make it a lot easier to work with for you. The next term that I want to talk about is parabola. Okay, and the parabola is the U-shaped curve formed by the graph of a quadratic equation. Okay, so usually these quadratic equations form a U, or in some case they form an upside down U like our free throw with the arc. The next one I want to talk about is axis of symmetry. An axis of symmetry is the vertical line that divides the parabola into two equal parts. Okay, so in just a little bit I'm going to show you exactly on a parabola where the axis of symmetry is and what it looks like. But for now, what you should know and what you should have in your notes is you should know that the axis of symmetry, the equation for that is x equals negative b over 2a. Okay, and that's going to be really important here in just a little bit. Finally, the last term that I want to talk about today is the vertex. And the vertex is the turning point of the parabola. Okay, so if you picture your free throw and shooting the ball up in the air, the highest point of that ball at the very, very top, that's going to be your maximum. That's going to be your maximum vertex. Okay, now sometimes if you're throwing a yo-yo down to the ground and it comes back up to you, the lowest point that yo-yo goes, that's going to be called your minimum. And again, both of them are vertex. You could have a vertex at the top, that's your maximum, or you could have a vertex at the bottom, that's your minimum. Alright, so that's just kind of some vocabulary to get us started, but let's look at a couple types of parabolas and how we can use these. Alright, so on your notes also you have these two equations written, and let's look at this first one here. Y equals x squared plus 2x minus 5. Okay, if I were to graph this quadratic equation, I'm not going to get technical today and get it exactly perfect, and you don't need to either, but if I were to graph this parabola or this line would look something like this. Alright, and again, that's not a perfect one there, but that's close enough. Okay, so we know that the vertex, the lowest point, this is the minimum right down here, this is our vertex. Right there, that's our vertex, okay? Now if we're looking for our axis of symmetry always goes through the vertex. So our axis of symmetry is a vertical line, it just goes up and down like this, right through the vertex, and we'll call that axis of symmetry. And that's that line that goes through the vertex. What the axis of symmetry is, that's the line where if you folded this parabola over on the other side, it would match up perfectly. Okay, our axis of symmetry could not be a horizontal line like this because then it wouldn't fold over and split the parabola into two equal parts. Okay, so our axis of symmetry it's always up and down, and it goes through our vertex. All right. Also, what I want you to notice about this equation is, notice that the a, remember our standard form, y equals ax plus b y equals ax squared plus bx plus c, or in this case minus c. Notice that the a in this part, okay, maybe it's imaginary, but it's a 1. And when the a is positive, the parabola opens up like a smile. So when you think positive, you think happy smile. Okay, the parabola opens up. On the other hand, let's look at this second example. Okay, and on this second example, we have y equals negative x squared plus 3x plus 7. In this case, the parabola looks a little bit different. Okay, in this case, our parabola might look something like this. All right, and if I were to label the vertex on this one looks more like our basketball shot here. So our vertex is up here at the top. It's a maximum this time. Okay, and if I were to draw the line of symmetry, you guessed it, it's a vertical line that goes right through our vertex. There's our axis of symmetry. Okay, this time if you'll notice, our a in front of our first term here is a negative 1. Okay, and again, that 1's kind of imaginary, but we know that it's there. Negative 1. So when your a is negative, then that means the parabola is going to open down like a frown face. Okay, so when you think of a negative parabola, you think sad, and an upside down parabola. Okay, one that opens down. So that's kind of 2 types of parabola, and there's more, but we're going to focus on these 2 for quite a while. And this is just kind of how parabolas look and where the vertex is and where the axis of symmetry is. So let's look at some examples now of real ones that we can actually find the vertex and the axis of symmetry. All right, so let's look at this example here. We've got a quadratic equation, y equals x squared plus 8x plus 15. And the first thing that we want to look for is our axis of symmetry. Okay, so if you remember, the equation for our axis of symmetry is x equals negative b over 2a. Okay, so that's our equation for axis of symmetry. Now we just need to find out what b is and what a is, and we'll be set. So when we look at our equation up here, we know that the a goes in front of the first term, the b is the second, and the c is the third term. So in this case, our a is kind of imaginary, but our a is a 1, and our b is an 8. So when we figure this, we get x equals negative. Instead of b, we're going to put an 8. And then all over 2 times a, but instead of a, we're going to put a 1. So it looks like that. So now when we simplify this, we just get x equals negative 8 over 2, or x equals negative 4. And that's our equation for that vertical line that goes through the center of our parabola, x equals negative 4. So up here I'm just going to write x equals negative 4. All right, now when I'm searching for the vertex, okay, remember the vertex is on the axis of symmetry. So we already know the x value of our vertex, but what we need to look for is the y value of our vertex now. Okay, and the way that we find the y value is we just substitute our x value into our quadratic equation and solve for y. So it will look like this. We got y equals, instead of x, I'm going to put negative 4 squared plus 8 times negative 4 plus 15. Okay, now I can just simplify and solve for y. But negative 4 squared, negative 4 times negative 4 is 16, so I get y equals 16. Plus 8 times negative 4 is negative 32. And then we just have plus 15. So 16 plus a negative 32 plus 15 gives us y equals negative 1. So I know the x is negative 4, and I know the y is negative 1. So the vertex then must be negative 4, comma negative 1. All right. So finally, it wants us to sketch a picture of this parabola. Okay. And again, you don't need a detailed, exact drawing here. What I'm just looking for is, can you label the parts basically? And is this a smiley face parabola or is it a frown parabola? We know that the a is positive in front of our x squared here, so our parabola is going to, we think positive, we think happy, so we know that our parabola is going to open upwards, just like that, okay? The vertex is going to be down here, and if I had to label that point, it would be -4, -1. That's our vertex, and then our axis of symmetry runs through our vertex, and the equation for that line then is x equals -4. Okay, so there's just a rough sketch of what that parabola looks like. We know that it opens up. We know that it has a vertex of -4, -1, and we know that the line of symmetry is x equals -4. Okay, so that's that example. Let's try another one.